Welcome, and thank you for joining today's webinar, Strategy, Tactics, and Tools for the Safety Lifecycle. This webinar is co-hosted by ISA and Mangan Software Solutions. I'm Michaela Cooper with ISA, and I'll be hosting today's webinar. But before we get started, I'd like to review just a few housekeeping items so you can know how to participate in today's webinar. First, in regards to the question and answer session, we have a Q&A session at the end of this webinar. And to submit your questions, you'll just want to simply type them into the Q&A chat box that's on the right-hand side of your WebEx screen. We ask that you do not use the chat box for the Q&A questions, just the Q&A box. And if we don't get a chance to respond to your question at the end of this webinar, we'll make a note of your question and we'll have the presenters reach out to you individually so they can answer your questions for you. Also, we will have 3 poll sessions within this webinar, and the poll feature is also in that right-hand side of your WebEx screen. So when we open up the polls, you'll just want to enter your answer in there. This is a good way to engage in the webinar for us to get your feedback throughout. So please participate in the poll sessions. And for those of you who have just joined, just want to remind you that you're on mute, and we'd like for you to remain on mute. The only people that are unmuted are the presenters. We have a lot of people that have registered for this webinar, so we cannot open up the phone lines for questions. And if you need to know how to dial in or to log in, you'll just need to refer to that confirmation email that I sent to you today. Additionally, once this webinar closes, a survey should pop up in your browser. The survey doesn't take more than a minute or 2. This will provide us feedback on what you thought about the webinar, and any information we can use to better our webinars in the future is much appreciated. So please just take a minute or 2 to fill that out. Okay, I believe that takes care of our housekeeping matters. So now I'd like to go ahead and introduce our presenters. First, we have Stephen Thomas. He is the SIS Engineering Coordinator for Chevron Global Manufacturing. He brings to the role over 19 years of experience in the refining and chemicals industries, and he is broadly knowledgeable in instrumentation, control systems, and safety instrumented systems. Stephen leads the SIS Central Engineering and Specialty Contractor teams for Global Manufacturing ISA84 Safety Lifecycle Implementation Program. The program involves the development and execution of over 240 individual process unit SIS upgrade projects and over 5,000 safety instrumented functions across 7 refineries. Stephen graduated from Auburn University with a Bachelor of Science in Chemical Engineering. He holds both the Certified Functional Safety Expert and ISA84 Safety Instrumented Systems Expert credentials in SIS Design and Implementation. He is also a licensed professional engineer in the state of Alabama. Next, but not least, we have Alaric Durkin. He is a project manager at Mangan Software Solutions. He brings to the role 8 years of experience in offshore vessel control technology and 2 years of both non-technology and software-oriented change management consulting. He supports global manufacturing and the implementation of Mangan Software Solutions Safety Lifecycle Manager software platform, for which he designs configurations critical to their ISA84 implementation program. He earned his Bachelor of Science in Economics from the U.S. Naval Academy and an MBA from the University of Houston. Welcome to both of our presenters. Now I'd like to go ahead and pass it off to Stephen to take it from here and kick off this webinar.
Good morning, this is Stephen. Thank you, Michaela, for that introduction, and I want to thank ISA for hosting this webinar. So I'll start with some background. The focus of our presentation is about implementing ISA84 Safety Lifecycle in existing facilities. And we're going to start off by providing an overview of the problems and challenges that anyone is likely to encounter and that we in Chevron have specifically encountered. And then we're going to talk about the solutions and good practices that we've employed in the process of our journey. So we've listed some topics here that we expect to prompt some discussion, but we'll touch on each one of these individually as we move forward. So as Michaela mentioned in the introduction, Chevron's currently undertaking an ISA84 Lifecycle Compliance Program. It covers 7 refineries in 3 countries, 240 process units, thousands of functions. 5,000 is a round number. Functions that at the least need to be evaluated, possibly updated, and/or new functions added. And obviously, with a program like this, it's not a quick fix. It's a multi-year execution plan with the end goal in mind to actually demonstrate full ISA84 compliance, and beyond that, continue to demonstrate ISA84 compliance throughout the full life cycle. And I think this focus is something that is fairly unique to our program, and hopefully something that will provide further insight on in this program. Many times the focus of the project is to get to compliance, and the life cycle maintenance is something of an afterthought, and many operating facilities struggle to continue compliance over the long term. And so one of the focuses of our program is to set up all of our manufacturing facilities for long-term success. And so we'll get into that more throughout the presentation. So one more piece of background here. One of the things that was immediately recognized with this sort of brownfield program is that you already have a lot of safety functions. Many of those functions are not originally designed to ISA84. Other functions may have been originally designed to ISA84, but perhaps have not been maintained per life cycle requirements. And so it's a challenge to know how to start, how to take the first bite out of the elephant, so to speak. And so we landed on a 2-pronged approach. Phase 1 we'll call operate and maintain phase, and phase 2, which is the capital program. So the idea of the phase 1 operation is to set up that sustainability organization and establish the work processes that are going to ensure long-term success. And then once those organizations are established, start ensuring that the existing functions are documented and tested, and start gathering prior use data to demonstrate that we are meeting minimum safety requirements. So one of the challenges here, of course, is if you have functions that were not originally designed to ISA84, you may not have a risk assessment to support any kind of reliability targets, and you certainly don't have SIL certified instruments to give you confidence in the reliability of individual components. So there is a lot of expert judgment that goes into determining what amount of reliability is adequate, what amount of testing is adequate, but that's simply the minimum due diligence that needs to be done set the stage for the capital program, because the capital program is a multi-year program. We cannot snap our fingers and get to full compliance with the standard overnight. So the capital program, step one is performing those risk assessments, for which we and most other people use LOPA. In addition to just ad hoc risk assessments, we're trying to develop and apply standardized risk assessment templates, which will then lead to standardized SRS templates, with the long-term view that we're trying to, number one, increase consistency and therefore efficiency in our engineering, and ultimately reduce life cycle costs by having the same solutions everywhere. And this will allow us to execute the 240 individual projects as quickly and efficiently as possible. So one last note on this. It may not be immediately obvious, but we just wanted to highlight that this phase one approach, which I think quite often could get overlooked, has actually turned out to be a low-cost, high-benefit effort, very high bang for the buck. Simply having people put eyes and hands on every function out there, and simply making sure that they're being tested and that they're operational. We found numerous cases where problems had gone overlooked, where a system was either only partially functional or in some cases completely non-functional, and it did not require major effort to fix these items. The main obstacle was identifying them, and then the fixes were relatively straightforward. So I want to emphasize that shouldn't be overlooked when obviously the focus and the investment is in the phase two capital program. So Alaric, did you have any further comments here?
Yeah, just a couple. So it's important to understand that from my perspective, which is that of the vendor providing solutions along this process, that phase one and phase two are not consecutive operations. They are in fact parallel. So in delivering solutions later on, we're going to see how we had to address really two different groups that are operating with two different end states in mind. So we will see that when we look at the tool that was delivered later on in the presentation.
Okay, thanks, Alaric. So with that, we're going to move to our first poll question. So Alaric.
All right, folks, now that we've kicked off the presentation, we kind of want to calibrate ourselves with the audience and kind of clue ourselves into why everybody dialed in. And certainly we appreciate you joining us. But for this first question, we want to poll you to see if you are undergoing a similar safety lifecycle journey. So please select whatever option applies for you there. And where applicable, is or was your experience in terms of greenfield or brownfield projects? So we'll just take a couple minutes here and let you guys answer those poll questions.
So rather than sit here in silence while you answer the poll, I just wanted to add that for those of you that want more information on this, Chevron did a presentation of the overall program at last year's ISA Safety Symposium, and that's available on the ISA website. There are some similarities between that presentation and this presentation, that presentation was more focused on the high-level strategy, whereas our presentation today, after this kind of brief overview of the strategy, we're delving down more into the details of the tools and work processes that were used. Okay, so I see we have our results in. Alric?
So this looks like a pretty good spread. I'm actually a little bit surprised by the high number of folks who replied with a yes currently option there. And it is kind of heartening to see that some folks are admitting that their answer is no, but we should. And it looks like almost nobody is soon to start a similar program. But then if you look at, for those who answered yes, for the experience, you see a high percentage of either brownfield or brown and greenfield, which is not unexpected there.
It's also interesting to me that we have a significant portion that responded, no, we don't need to. And I wonder if that's because it was done long ago or you guys feel like you're just in good shape. And my comment on that would be what we found was at most of our facilities, depending on who you asked, a lot of people would have said we're in fine shape. And they're in the process of peeling back the onion. That's when you reveal all of these little safety life cycle problems that kind of add up.
Yeah, maybe we'll see that answer change by the end of the presentation.
All right, so thank you for that, and we'll continue on. So in this slide here, I'm just kind of highlighting the structure of the first half of the presentation here. We want to highlight some of our focus areas and what we're calling our key wins. So we'll talk about organizational readiness, verification of the legacy functions, standardized SRS content, work processes, and prior use data. And then most importantly, we're going to be looking at these through the lens of the safety lifecycle management tool. And so the format here is that I'm going to describe some of the problems and challenges that we had along with Alaric. And then once we've gone through that, we'll kind of switch roles. Alaric will take the lead, and we'll talk specifically about how we develop work processes and tools to address these problems. So starting off, design of the SIS organization. So one of the things that we recognized early on was that the skills of SIS testing and maintenance are not the same as basic E&I skills. Now, for example, knowledge of common mode failures, the importance of proof test coverage, et cetera. These are not things that are in the basic E&I toolkit. And so the first step for us was defining these required skills and competencies and starting to track them. And to facilitate that, we created designated SIS O&M coordinators at each site, and also SIS engineers, and then a dedicated SIS group reporting to the O&M coordinator. And then subtly but very, very importantly, originally many of these teams were based out of technical organizations, which with the history of SIS, it kind of originated out of technical organizations, and that knowledge has stayed in the technical organizations. And so we're making a conscious effort to push that knowledge and work processes out of the technical organizations into the maintenance and reliability organizations. And having these designated contacts are a key part of that. So we'll get into more detail on that later. Alaric, you have comments?
Certainly. So let's again look at scope. So you have here a central team of corporate leadership really driving change from the top down. And then now you have program, project, and technical managers kind of sitting in the middle of all of this. And then you also have refinery team leaders and technicians at the bottom of this new organization. So from a change management perspective, and again speaking from a vendor to client relationship perspective, you really need to plan out how to handle client-vendor communications and kind of figure out early on in the process who gets what report and when. And we'll see that pop up when we get to our lessons learned at the end.
Thanks. I just want to add that you'll see throughout the presentation here that that Alaric and his team bring a little bit of a different perspective. From an operating company, oftentimes the organization is what it is, and having an outside group come in and try to understand that organization and implement work processes and software really forces us to understand what our organization is doing. And so we'll see more details on that later. Verification of legacy functions. So I started off earlier by stating that we have a large inventory of existing functions, which we just generically call legacy instrumented functions. Many of them are clearly safety functions, although they may or may not have a formal risk assessment to back that up. Others, it's unclear whether there should be safety functions, and we await a risk assessment to back that up. And so ultimately, the first problem is simply to record all of these protective functions and document them as carefully as we can. And only then, after we've gathered the data, can you make a decision on what happens to that legacy function. Options being to grandfather the function, to replace it, or ultimately to decommission it. And one of the challenges that we faced with our centralized program is we need a standard process to ensure that, number one, we're making the right decision on these, and number two, that we're making the same decision from site to site in a consistent and efficient way. And then in the interim, we have the problem of how do we do our due diligence to make sure that we're providing adequate safety. And one of the key questions there is about testing frequency. So in the pre-ISA84 world, the testing frequency may not have been specified, may not have been recorded. And without completing full ISA84 compliance, which takes time, we have to make decisions in the interim. And so we've set up standard guidelines based on past experience for both maintenance practices and testing frequency. Alaric, further comments?
Yeah, just one comment on the use of the term grandfather there. You know, it's almost my job to say that grandfathering is not it's not a process so easy as just snapping your fingers and then it's done. So it was very important from both my perspective and Stephen's that we build and develop rigorous and like he mentioned, standard evaluation guidelines that could be used across the enterprise.
Thank you, Alaric. The next challenge we faced was what does an SRS look like? And for anybody that's worked on a safety requirements specification before, you already know that frequently an SRS is not a single document. It's multiple pieces of information that could live in multiple systems. Many of these systems are really outside of the scope of control of the SIS engineer. The example I give here is P&IDs. Obviously, the P&IDs are an important reference for the SRS. We want to ensure that if the P&IDs change, that it stays consistent with the SRS, but we simply can't take ownership of the P&IDs. It's out of our control. And you could go on and list many, many other items in here, from cause and effect to loop diagrams and so on. And so what you need is more than a document, but a way to integrate all of the required information into one place. And beyond that, we want it integrated in a standard way. You'll find that depending on what SIS engineer you talk to, the definitions of what belongs in the SRS can be wildly different. And the ISA84 standard doesn't really help. It lists a kind of a checklist of minimum SRS requirements. However, beyond that, there are many, many shall paragraphs in ISA84 that require that different things be considered, different items be incorporated, different work processes be followed. So how do you document that that you've complied with the full standard? And that's one of the challenges we face in trying to come up with a standard format. And then beyond the standard format, we really ultimately want standard designs. And that's where we land on the idea of SRS templates. The idea being that for a specific safety instrumented function in a specific service, we have an SRS template that covers the typical design for that function. And by that I mean, for example, if you want to know how to do a low pass flow trip on a fired heater, we have a template for that that tells you what instruments, what valves, provides cell calculations, etc. With the idea being that we are not only maximizing consistency, but maximizing efficiency for the program. Alaric, comments?
So one comment here on that bullet point that says standard SRS format. SRS, remember, is safety requirements specification. So as an industry vendor, I can confirm, via a unique insight, the fact that each organization handles the safety requirements specification content differently. You see everything on the spectrum from very lean content to very detailed. But by the end of this presentation, I hope that you'll see that because of the Chevron Global Manufacturing desired end state of continuing the safety life cycle as long as it goes, and not just getting to compliance, but continuing compliance, you'll see that within our SLM tool, we had what is probably the largest and most all-inclusive configuration of SRS data collection and verification we've ever conducted.
Thank you, Alaric. As I hinted at on the previous slide, something that goes hand in hand with the standardized SRS are the standard work processes to support it. And I think this is one of those aspects of life cycle management where many organizations fall down. A big part of the ISA84 standard is about the required verifications and functional safety assessments that have to be performed. And obviously we want to perform those in a consistent way that will allow us to demonstrate compliance years after the initial project. So the key requirements here are we're looking for a structured method. We want every verification and every FSA to cover the same minimum items, to have the same structure, and to have the same let's say the same types of participants. They're required participants with required competencies on these work processes. And then finally, we need that standard revision tracking and approval flows to make sure that the system that we set up initially continues to be followed in the long term. And then to audit that, we have a deviation process to support that. So Alaric, further comments here?
Yeah, just another look into the future here. In the presentation, these are just 4 of the many work processes that global manufacturing had to adopt and implement. And we will look at how we implemented these through the software platform. But keep in mind that, again, these work processes need to be harmonized across what is effectively a geographically diverse enterprise. So when we talk a little bit later about what we call a world tour, you'll see why that was so important, because that harmonization across the 7 refineries was very important in making this happen.
All right, thank you. So I feel like now that we're doing the presentation live, I feel like I've just been laying out a laundry list of problems for the last 10 minutes. So this is the last slide of problems, and then I promise that we're going to get into solutions shortly. So finally here, prior use data. It looks so easy, but it's not. What we found is that even if our operations and maintenance organization have been performing testing, there's no mechanism for collecting and analyzing that data. It may go into a maintenance management system, it may go into a file cabinet, but one thing it definitely doesn't do is magically transform into prior use data for SIS engineers. So we need a standard way to group and categorize devices, because prior use data applies to specific devices in specific services. We need a standard way to analyze the data and approve the data. And finally, the overall process needs to be as automatic as possible, because experience tells us that if gathering prior use data is hard, it likely just won't happen. And so why do we want this? Initially, of course, we want more accurate SIL calculations. Assuming that our prior use data is good, it would allow us to reduce hardware fault tolerance requirements. In some cases where SIL2 was requiring redundancy, the data could support using a single device, so that is cost savings for us. And then ultimately, the goal of prior use data is increased safety and increased confidence that you know you are safe. If you're simply assuming failure rate data out of a book, you don't necessarily have the same level of confidence as if you've proven it in your plant. So Alaric, any comments here?
No comments here. I think we can press on.
Okay. So now we are going to move into our second poll. Go ahead, Alaric.
So speaking of a laundry list of problems, with this next poll, we do want to understand for the audience which of the previously mentioned aspects are most important to you. And with this one, please select all of those options that apply. What we hope to see with that first question is, are we far off the mark, right? Are we kind of chasing the correct targets here? And that's with regards to your opinion, right? Stephen, in the leadership at Global Manufacturing, they've kind of come to the understanding in speaking with other SIS leaders. They are, in fact, not alone in worrying about these various topics. And then for the second question, I want you to think about how many different databases, systems, or programs you require to demonstrate this standards compliance. And for instance, where do you keep your loop drawings? Where do you keep your logic solver programs or calibration certificates? You know, my suspicion here is that if you really map out where these things live in your organization, we'll see those responses creep higher to the 3 or 4 or greater than 4 options.
Yeah, and quite honestly, I don't want to influence your responses, but I'll be very surprised if a lot of people say one system, because what we found is the reality is that's just really hard. You're always going to have to live with multiple systems that will have to work together. So since we're running a little bit behind, why don't I move to the next slide while the poll's still open, and Alaric can give the overview of the next part of the presentation, then we'll come back to the poll results. Okay. Oh, they just popped in. So take it.
Okay, well, so I'm scanning the results on question 1 there, and we're seeing, you know, greater than 30% indication for almost every one of those options. And it looks like option D there, which is templates, yeah, that one has the lowest response rate. Kind of interesting. We have a couple slides on the use of templates. Maybe we can change people's minds there. But certainly the highest one looks like the evaluation of existing systems.
Yeah, that's interesting to see and makes me feel good. That it's a common problem. Everybody's in the same boat, and I think we're going to show in the next section some powerful ways to manage that process. And on the templates, it's too bad that we can't elicit responses, but I wonder if the templates are not so important to people because a lot of people already have them. That's based on my talking to people at other companies. The templates have been around for a while in some form or another, and so I think what's a little more unique for us is the focus on the overall life cycle and taking our existing functions and bringing them into compliance.
Agreed. And yeah, the other one that jumps out to me there is the 56% response rate on SRS content.
Yeah.
And then with the second of those questions, how many different databases, et cetera, do you use? Yeah, 41% are greater than 4. So not really unexpected there, but we're in double digits for just one system.
Yeah. So if you guys that are using one system, give me a call. I want to know what system. All right, so moving on, I'm going to hand it over to you, Alaric.
Got it right here. Okay. All right, so again, folks, I'll start driving. Alaric Durkin, Project Manager at Mangan Software Solutions, and again, I want to thank everybody for joining us today. So up to this point, we've talked about how Chevron Global Manufacturing has formulated their strategic and tactical key wins. And they recognized early in the planning process the need to adopt an integrated safety lifecycle management tool to help them realize these objectives. And that's where I come in. I was the engineer for the deployment, really the configuration and deployment of the software throughout the enterprise. And I'm now kind of the customer support program manager. So I've been working with Stephen and his colleagues actually since the deployment of the software. Now, over the next several slides, what I want to show you is how we, the team at Mangan Software Solutions, helped fulfill the program's key requirements by configuring and implementing our Safety Lifecycle Management, or SLM, software platform at the 7 refineries. And it's a little bit more than just handing over software. There's a deployment process that we do have to talk about. Now, throughout the discussion, you'll see different ways in which the common tool of enterprise software encourages discipline, such as in the standardization of safety requirements, specification content, and then just as important, it's going to be a lot of the approval processes along the way. And then in the final bullet here, you should understand for global manufacturing, it's not just enough to become compliant and then also continue compliance, but also to be able to show compliance. And technically, you want to monitor non-compliance as you're working towards it. But that's why in several cases we focus on reports made available in the software as we progress through the safety lifecycle, right? Because this is a process that is ramped up and then will continue hopefully forever. Stephen?
I just want to very quickly add here that the next few slides, we're going to be getting more down in the details. I was actually very sensitive to wanting to make sure that this part was not an infomercial for Mangan's solution. And so we've tried our best to focus on the process that got us to the tool that we needed. And although all the screenshots are obviously based on the product that we use, we think the learnings and the work process are an equally valuable part.
So continuing on, this first slide we talk about enabling the SIS organization, and it really speaks to the change management aspect of deploying enterprise software. Now we begin the process by talking to the organization adopting the software, right? So you don't want to start with just a handover of software. You have to talk in terms of needs and requirements. So once the decision had been made to implement our SLM platform, we began to define its role within the organization by holding what we call a requirements discovery workshop process. And in our case, we started with a week-long conference room workshop in which we gathered global manufacturing's corporate and technical leadership, the refinery's SIS coordinators, and the organization's IT project management, along with our team, to review the program's key requirements and then really talk about the nuts and bolts of how to achieve them. Right, so our discussions ranged from database structures to SRS formats and anywhere from project workflows to application hosting. Now, it's important to understand that a discovery process like this unveils and elucidates the organization's processes, both good and bad, especially when you're deciding which of those processes to automate in software. And that's why on that final sub-bullet, we recommend you allow enough time to discover and configure what you would consider the right processes. Because when done well, this communication leads to an iterative process of inquiry, discovery, gap analysis, and eventual gap closure through the application of software design. Well,
I just want to add here that I cannot overemphasize the importance of this process we're talking about on this slide. And that we in Chevron, I think, going into this process, we didn't know what we didn't know. I think there was an assumption going into it that everybody had work processes that were basically the same, and it was only when you dig into the details that you find that 7 sites all do things at least 7 different ways, and often more than 7 different ways, depending on who you spoke to. And so the process of uncovering this and then aligning on standard work processes was worth its weight in gold.
And that's really the power of bringing in you know, a neutral third party to observe these discussions. And some examples we'll look at, a lot of the workflows that we see represented in screen captures or actual workflow diagrams, what you see here was the product of 2 to 3 months worth of iteration on the part of Steve and myself and a couple other members of the central team. Right? And kind of to sum this up, you know, the SLM platform that we deployed really ends up becoming a vehicle for refining the organization, right? And again, acting as a neutral third party, you know, I get to come in and start asking maybe the simple questions, but the other questions people are afraid to ask, right? You know, we kind of avoid the politics. And the entire process provides a common ground for communication. For instance, the label for what we call throughout the presentation this quote-unquote legacy function had not even been decided until we sat down in that conference room at our first discovery workshop and said, well, what are you just going to call this thing, right? We have to give it a label in the software. Any other comments, Stephen?
No, I think we can move on.
All right, so this slide shows one of the deliverables from that discovery process. This is the first 4 pages of what ultimately became a 10-page workflow. And I'm going to quote Stephen on this. When he first saw it, he said, well, that's one heck of a workflow. You know, and this is one of those things that we had worked on for 2 to 3 months.
Oh, yeah.
Although I call it a day in the life of an SIS organization, it really illustrates how we mapped the life of a safety function from conception all the way to decommissioning.
Somebody is not on mute.
And then what you see here is not just a diagram of the software, though it will contain some aspects of it. This is really the work processes global manufacturing undertakes in their program, where some of the swim lanes do in fact represent the software workflows or changes in the database objects. Now, I've blurred out the details, but when you start at the top left with the collection and recording of legacy function data, and then we're going to talk about proceeding through the parallel phase 1 and 2 portions of the program. We're going to be talking about the most important sections of this workflow throughout the presentation. But again, before I proceed, I want to deliver a sense of scope. Right, through the discovery process, we took what was effectively 1 page of requirements, and Stephen and I and a couple other members of the organization mapped it into 10 pages worth of workflow. Now, we don't show it in the presentation, but all of those software touch points identified in the workflow eventually became 73 pages of software requirements. Right, so the lesson learned should be this. You know, if you can't diagram your work processes at this level of detail, you won't be able to configure them into the software and get the tool that'll help you along the safety lifecycle journey. Right, so moving on, with this slide, I want to summarize how we deployed the SLM software platform once the discovery process and software configurations were complete. Though the configurations, you know, things like the touch, feel, and functionality within the software are the same, we actually deployed what we call separate instances of the software, one of which to the phase 1 group, which is the refinery SIS teams, and also the phase 2 group, which is the capital projects team. And then the 2 of those, plus myself, share a staging instance which acts like a sandbox, really in which either group can test new configurations for the software. Now, providing the separate instances, you know, I hope you understand, is an elegant solution to handling the 2 distinct yet parallel program workflows within that safety lifecycle journey. So it's a little bit small, but you should be able to see where the phase 1 personnel begin by collecting legacy function data, building and executing on operate and maintain program for those things that currently exist. The phase 2 team in parallel is executing the ISA84 program, and remember, they're doing so with a separate database. Same configuration, but a separate database.
I'd just like to make a quick comment here to clarify what we mean by parallel work processes. So going back to my furnace pass flow example, that function may exist in some form currently. It may be in operation, and our O&M team is making sure that that current system is documented, is being tested, and that the tests are being recorded for prior use data. And then in parallel to that, a capital project may be beginning to work on a upgrade of that function, which may be installed in a turnaround 3 years from now. So obviously those two can't coexist as the same data. It's two different sets of data that only converge after the turnaround.
You got it. And yeah, what you see on the right-hand side of that is where the two-pronged approach does converge. As we kind of port the ISA84 verified functions over to the database that does continue in perpetuity. Right, and it's important to remember that this approach is actually transparent to most Chevron personnel involved because we deployed the application to cloud servers, right? So this is hosted in the cloud, accessed via web browsers. So the phase 1 and phase 2 participants really only concern themselves with the aspect of the platform that they use, while myself, Stephen, and a couple IT business analysts manage this setup in the background. Right, now I want to talk on this slide a little bit more about the key requirement Stephen mentioned earlier about configurability as requirements change, because that's where we find the true impact of having a staging instance, which I sometimes refer to as the sandbox. So we have an internal user committee made up of Chevron personnel from phase 1 and phase 2, along with a couple IT business analysts and myself. And we're tasked with providing feedback on all aspects of the software's adoption. So in addition to monitoring cloud server performance, web page load times, and things like end user activity metrics, most importantly, we continue to validate the application's design intent as it is used at the refineries. So where new requirements may be discovered, and some have in fact been discovered, we can build and test their configuration in our sandbox staging instance. And we'll see how that works on the next slide. But first, Stephen, do you have any comments?
Just very briefly that, you know, Alaric showed you the 10-page workflow, and then there were probably, I don't know, 500 database fields that were defined. It's no surprise, I think, that we didn't get it 100% right the first time. So this is, I think, a reality of any software implementation where it's going to be an iterative process. As more and more people use it, you're going to get more and more feedback, and you have to have a structured way to deal with it.
Yep, long-term enterprise installations. Right, so here I'm trying to illustrate that any new features, version updates, or bug fixes can be deployed to the cloud server near instantaneously. And I say near instantaneously because, well, really my development team and I subject any updates to our internal QA process, and we also adhere to the Chevron IT management of change process, so it slows us down a little bit. But the application architecture was designed to allow rapid updating such as this. And it's important that we can make these updates at any stage of the safety lifecycle, anywhere that we need to. In fact, we are about to conduct a user acceptance test on an enhancement that Stephen and I have been working on for safety function SRS content, and that's based on feedback from the Phase 2 engineering team. And before we move on, just want to point out this ongoing configurability was a major factor in the organization adopting the platform. And kind of a key phrase here is that it allows the software to remain relevant longer than just the people who first envisioned it. And that concept speaks directly to the intent of this program, to not only achieve ISA84 compliance, but also build a sustainable organization in which compliance continues.
So Alaric just briefly threw out there that this was a cloud-based application, which many people may not have been aware of. And so I just wanted to quickly highlight that we were quite worried about that at first. But having experienced it, I think that we found that our IT staff fully supported it and encouraged it, less work for them. And from our end user perspective, it's much easier to manage for us. If we have a new functional requirement, a new work process, it can nearly instantaneously be implemented at all 7 sites. So if there's anybody that's on the fence about cloud-based technology for this kind of application, we would definitely do it again.
Thanks. All right, so let's talk about the implementation of the software throughout the organization. And we start with the legacy functions because that's what's in place right now. All right, so phase 1 began with the collection of legacy function data, where the newly established SIS organization really deserves a lot of credit here because what they've been doing is a massive undertaking. And in fact, it's so big that some of the refineries are still working hard at it. So the refinery personnel have spent probably hundreds, if not thousands of man-hours collecting functional data in whatever pre-verification form they could find it, which could be something like Excel spreadsheets, PDF documents, maybe physical binders of data. But they updated this information as best they could with unit-by-unit instrumentation field surveys. And then they organized it for loading into the software database. While in a parallel effort, my team and I deployed the SLM platform in what we call a refinery-by-refinery world tour. And I use that term to give you an idea of the scope involved in case you've never been part of an enterprise software rollout. It's actually a significant logistical undertaking for both organizations involved. On our side, we trained 85 end users and loaded thousands of protective functions worth of data into the database at 7 refineries in about 9 weeks start to finish. From the refinery's perspective, their SIS teams dedicated 3 full weeks to wrapping up the data prep, getting trained, and then quality assuring the functional data once it was loaded into the application. And having personally participated in 4 of those 7 deployments, I can speak directly to the immediate impact these efforts had in standardizing the organization. The world tour took wildly different forms of functional data as it existed, collected it at geographically dispersed refineries, and then transformed it into a database of standardized information made available to the corporate leadership, the technical teams, as well as the individual refineries. Now that the data was all in standard form, it could be put through an evaluation process. So on the next couple slides, we'll talk about the use of evaluation checklists and then what we call upgrade or decommission workflows that are made available in the application. All right, so we're going to zoom in a little bit on our lifecycle workflow and just want to point out that the initial phase 1 efforts occur at the very beginning. And with this screen capture, I want to show you how we configured the application to handle legacy function data in what I call an SRS-like manner. Right? Now, as Stephen would say, the legacy function itself is just an interim state. Right? The organization doesn't intend on keeping legacy functions as they are. And instead, on a function-by-function basis, they're going to make the determination whether to keep and take credit for or otherwise decommission the function. So it makes sense then to organize the legacy data in a manner closely resembling what it might become, such as the safety requirement specification structure like you see here. And again, I want to stress the degree of adaptation involved. My team and I changed a software platform used primarily as a compliance tool to, in this case, accommodate admittedly pre-compliant data entries. Stephen?
Yeah, that's a good point, Alaric. We should emphasize that the legacy function from a software perspective was a new object that the system had to learn how to deal with in a system that dealt with SIFs. And one other thing I'd like to point out is we say SRS-like data. Specifically, it's a subset of the SRS data because, as Alaric said, the LIF is just a temporary state. The legacy function. It either eventually becomes a compliant SIF or it's decommissioned. So rather than reinvent the wheel, we simply took a subset of the data that you would expect for a compliant SIF and used that as the basis for our legacy function documentation.
So on this next slide, we talk about what happens to the legacy functions while they're being evaluated in that interim state, right? And this is such an important key requirement stated for the organization that I'm actually quoting a senior member of the global manufacturing team with that slide title of Test Baby Test, right? Now, here again, you'll see the benefits of employing a common software tool across an organization like this, where testing procedures or frequency may not have been previously identified. The Phase 1 teams could now specify nominal testing frequencies and establish some form of standard test procedure across the enterprise. Now, standardizing test procedures was one of the expected positive outcomes of the effort, but as the refinery SIS organizations adopted the software platform and really started taking ownership of SIS testing, which in some cases was for the first time, they opened the door for further management discussion, and then really started asking questions like, how do we report demands? How do we approve or manage bypasses, right? So you kind of see here that they're starting to formulate the management of the operate and maintain phase of the safety lifecycle.
So I would add to this slide that one of the very effective things that were done by the Phase 1 operation was instituting SIS, I shouldn't say SIS, legacy function test and demand metrics, which began life as a manual report done monthly, which simply tracked tests that had been done, tests that were overdue, trips, both spurious trips and successful trips. And what this is representing is the next leg of that, where we found that it was very effective to raise the visibility of those data metrics, and now we're making the effort to make it more automatic, more reproducible, and more likely to last into the long term.
Very good. Thanks. Very good points there. So in a couple of slides, we'll address, where the life cycle for a legacy function eventually goes. But first, on this next slide, let's take a look at the outcome of this initial effort. All right, so this slide shows a screen capture of what we call the operate and maintain module out of the SLM software, wherein you see the collection of test groups, or you could think procedures, and an example list of the legacy functions covered by that test. And just as a quick note, all of this information has been made anonymous for the presentation. Now at this point, the Phase 1 refinery teams have recorded in very standard form the legacy functions that are in place. They've kicked off an enterprise operate and maintain program, and now it's time to move forward in the evaluation of legacy functions.
So I would just like to very quickly add here something I should have mentioned earlier. If we have a legacy function in place and we are shooting for full ISA84 compliance, that doesn't necessarily require a rip out and replace of what's there. In some cases, compliance is a paperwork exercise to make sure that your documentations and your procedures and your verifications and validations have been done. And in those cases, all of the work for defining test procedures and gathering data for the legacy functions is immediately transferable to the ultimate compliant SIF.
You got it. Very good comment there. because as we move along the program workflow, we actually get to those steps and sub-steps which drive what I call the final determination of a legacy function. So we're going to be looking in on some closer points in the workflow. Right, so as Stephen kind of alluded to, that final determination begins with the completion of a 21-item evaluation checklist, which you see represented in the screen captures from the software here. And again, I did blur out the individual checklist line items to protect their evaluation criteria.
We did a lot of work to get these things. We don't want you all just stealing them.
A lot of discussion, right? Now, you should kind of key in here that this represents another form of standardization when we talk about discipline that was mentioned earlier, right? So these evaluation items were developed by the central team, but are enforced at the refinery level through the software. Now, within the application, this checklist acts as a prerequisite review on every legacy function before undertaking what I call a resolution path on the lifecycle workflow. Right, so as we move along this lifecycle workflow, you see there's a couple different paths that we can follow and lead towards the eventual end of the interim state, which is the legacy function. Right, so zooming in here on the workflow, we have ultimately two options for resolving that legacy function. Number one of which is considering the function creditable and then eventually ascribing some SIL level to it. Right, in the software, this involves a workflow to what we call upgrade the database object to a safety function. Path number two would be to take no credit for the function and in some way, shape, or form decommission it. Right, in the application, this would archive the functional data that had been built up to this point. Now, either option involves workflows which are managed by stage gate checklists in the software, which you see in these other screen captures. Now, you don't see the application logic in this section of the workflow, but in those instances where a legacy function is upgraded to a credited safety function, we tied the commissioning of the ISA84 compliant function to the subsequent decommissioning of the related legacy function within the database. You know, like Stephen said, you know, some of the equipment may remain, but at least in the database we make that change. Right, so this creates a figurative switch that gets flipped between the pre-verification function in phase one and the ISA84 compliant safety function verified by phase two.
Well, Alaric, it occurs to me it may not be painfully obvious what we mean by all of these checklist steps. So let me just give a couple of examples here. So on the decommissioning checklist, if you're actually decommissioning a legacy function, there's a lot that has to happen, and this gives us a convenient checklist format to make sure it does happen. Examples, P&IDs need to be updated. The device or devices need to physically be removed, and wires may need to be relabeled, et cetera, et cetera. Every activity that you can think of that's involved in decommissioning the function can be captured as an item on the checklist, and in fact, these checklists are user configurable so that we can update them as we get more experience.
Got it. Thank you. So we've run the legacy function to its quote-unquote end, and that's where we can talk about the phase two activities. Now, phase two begins with the development of what we call SRS templates, and then continues with the specification of the project SIFs. Right, so this is done in the separate phase two instance, where you see a different mentality, right? Where the phase one team is working with what they've got, so to speak. In this case, the phase two team needs to achieve consistency and efficiency. You'll know Stephen mentioned those earlier, and that'll be through the standardization of SRS content. Right, so we supported that effort by configuring the software application with features like custom fields, workflows, reports. We'll talk about some of those in the upcoming slides. But what's also important is the creation of what we call enterprise templates, where these are defined by the central engineering team to provide a baseline of standard data which speeds up the development of actual SIF SRSs. And this is where Stephen, you'll hear him mention the approximate 25-to-1 leverage in creating the thousands of project SIFs during the program. Right, we're also going to see how Phase 2 reports on SIF deviations can be created based on these standardized templates. Stephen, any comments?
No, let's move forward to the example.
You got it. All right, so now we're in a new section of our lifecycle workflow, and it's quite a large section, in fact, because we rope in all of these SRS templates. So on the left here, you see a screen capture with examples of those SRS templates, in this case about a dozen that might be referenced for code generation units. The other example process unit types you see here for things like Coker units, hydroprocessors, various versions of SRU, and these are really only a small sample of those being developed by the Phase 2 team. And then on the right, we've zoomed in on the 3 paths for implementing ISA84 safety functions, which have corresponding workflows in the software. Where the top path follows from the upgrade, quote unquote, of a legacy function, in which case you can specify the appropriate template to apply once the evaluation on that legacy function is complete. The middle path explains the software option to copy the baseline SRS data directly from the template, right? And again, I want to emphasize copying directly from a template. And then the bottom path shows how, should you choose to start building an SRS from scratch, which, you know, there's going to be those one-off opportunities, you can, at any time in the future, specify the applicable SRS template.
So I'll just briefly add on this slide that this is all about consistency and efficiency. When we're talking about 5,000 functions, even if I only get the templates half right, that's half my work that I've reduced. And then beyond that, we'll talk about the importance of consistency and how we're helping to ensure consistency in some of these later slides.
Yeah, so no matter how you develop the SRS, the end result is that you have a standardized safety requirement specification built within the software. Right, so this shows an example cover page of the safety function SRS, which is one-click printable for the Phase 2 team from within the application. Right, so at this point we've established the SRS templates and described how they are really created in baseline form. So we need to look at the further development of safety functions. And in particular, we're going to talk about how deviations can be handled, and it'll be deviations from those templates. Right, so we're still moving along the overall safety lifecycle, and this shows the project steps and associated database actions for the safety function verification process. And we're first going to zoom in on the SRS deviation portion of that workflow. As we focus in here, you see the importance of, really the importance that Phase 2 personnel place on reporting deviations from the established template, and this feature is just one of those organization's key requirements. So the application conducts a field-by-field SRS comparison against the template on about 100 data points, and then reports them like you see in the screen capture there. Now, in addition to the variation and proposed justification, the Phase 2 personnel can come in and indicate the impact of change in various categories: safety, reliability, cost, operability, maintenance, and life cycle. And then deviations, and it's important to note these are the actual safety function. Where it deviates from the template gets approved up to Stephen's level, typically Stephen's level in the software. And just important to note here that that deviation reporting and approval process is another one of those what I call elegant solutions to replace what is originally a paper-based and manual process when Stephen first envisioned it.
So I would just add on this quickly that I want to emphasize that this is item by item, data point by data point. and if you really think about this, it's extremely powerful as a life cycle tool that ultimately you'll be able to run a report that tells you every place where one of your safety functions didn't follow the template best practice, where it didn't follow a corporate standard, et cetera, and will forever have the approval of those deviations documented and justified. So this is one of the configurations that we added into to our implementation that we've been extremely happy with.
Yep. So in conjunction with the ability to just copy over the baseline data from a template, you're really looking at, again, the consistency and efficiency, because when the majority of your work is standardized, it's easier to report on the small percentage that is in deviation. So this is not going to necessarily eat up a lot of Stephen's time. Right, and kind of moving on here, just talk about safety function required documentation. And you'll remember from earlier that a fully realized SRS needs to link to other documents such as things like calibration certificates, P&IDs, instrument data sheets. And therefore, as part of this verification process, the software application reports on whether those requirement document types have been identified and linked on a per function basis. Right, so the screen capture you see here shows the identification of a couple of those missing documents.
So this is very important to the 41% of you that have more than 4 systems that you're using for compliance, and this is a method for you to link into those systems, because you can link to whatever kind of document you want, and have the ability for the software to verify that the documents you're linking to actually exist.
Got it. So up to this point, we've been talking about various options like the application of SRS templates, deviation reporting, linking other documents, all of which build up to the functional verification of these safety functions within the life cycle. So let's jump into how that works. So to meet Stephen's needs, we designed a recurring SIF verification approval process within the software. I'm just going to zoom in on this, where you see kind of those steps summarized in the screen capture at the bottom of this slide. Right? These are the project approvals we configured for global manufacturing, which mirror their capital project stage gates. So you'll see that the life cycle starts with the baseline version of SRS, then moves on to initial SRS and continues up to installation, commissioning, and eventually decommissioning. Now, I call it a recurring approval process since at approval, we end up saving the safety requirement specification for that project stage, but the functional data within the database remains evergreen as the Phase 2 team moves on to the next stage. And you'll also see here, though I've blurred it out, at the commissioning step, the software has a conditional or a couple conditional logic requirements, right? These are going to correspond to status within the associated legacy function, if applicable, and the overall approval of the SIS for that particular unit.
So why is this important? I would say we probably didn't realize its importance initially. We actually had various stages of the SRS defined in our SIS standard, but what we realized as we were working through the work processes was the reality was we live in a project environment. So even more important than the SIS stages are the project stages. When I get to the end of feed for the project, I have to issue a feed package. And so therefore, I need a point in my work process where I have a approved SRS at the end of feed. And so it's details like this that were fleshed out in the requirements workshops and ultimately implemented.
And yeah, I just want to point out here that, yeah, like Stephen's talking about there, we didn't start from a base case in implementing the software. You know, he and the Phase 2 team, along with myself and the other central team members within global manufacturing, kind of ideated, idealized the, the project stage gates that needed to apply here, and then put them into the software tool. And it wasn't the other way around. We didn't dictate to them how the tool would work. This is their way of handling it, and we adopted it for the software. Right now, that's the final piece of the safety life cycle and the final part of the software integration that we wanted to cover in the presentation. From this point, the several other remaining pages of that workflow deal with the continued operation and maintenance of the safety functions. And it does lead all the way up to eventual decommissioning, but we have time for just one final poll before we move on to lessons learned, so let's take a look at it. Right, so to kind of wrap this up, we want to ask folks, do you apply LOPA or SRS templates? And then for those that apply templates, assuming you manage deviations from them, that's part of the point of having templates, how do you do so?
So while you're considering those questions, I would add we've saved at least a few minutes for questions. So if you have questions, please start entering them now. And then also, since we're nearing the end of the presentation, I'd like to remind you all to please look for us at the 2016 ISA Safety Symposium. Mangan will be presenting their Mangan Software Solutions will be presenting their SLM software in the exposition, and I expect to be presenting a paper in the symposium, so you can please stop by and see both of us.
Yep, certainly hope to see you there. All right, and the poll results are in, so we have a majority of folks applying LOPA or SRS templates. And then it looks like almost even distribution between centrally approved or site approved. And then smaller percentages where you have SIS engineer alone as the approval authority or not managed. Right, so a small percentage there.
Interesting. Yeah, I don't find these numbers surprising. I have heard a lot of people say they use templates. I think hopefully what we've shown in our presentation here is that it actually takes a lot of work to use templates effectively and efficiently. And I guess it's not that we have any great font of knowledge on the problem, but what has happened is we're faced with this very large program, and so we are forced to find ways to be efficient and effective. So hopefully you found that helpful.
Speaks a lot to the organizational discipline, and that kind of takes us into our final slide, which is lessons learned. So Stephen, you want to kick off here?
Well, I think I may have covered a couple of these things already, but specific lessons. Establish and communicate new conventions early and frequently. This is really part of that discovery process that we talked about, which in our case was several months and was certainly not linear. We had workshops. We came up with new conventions, which prompted more discussion, which then got worked in the next workshop. And you have to allow the time to let that develop in an iterative fashion. Defining reporting requirements before workflow steps. Let me let you talk about this one.
Oh, that's definitely in my domain. So this is where, in particular with the Phase 1 group, they were more keen on what their, really defining what their next action should be. And it was an uphill battle for me to keep them focused on the longer-term desired end state and kind of keep them in line with the Phase 2 personnel. And then part of that feeds into the next bullet there, which indicates to iterate on a design freeze basis with the software, where, again, with the Phase 1 personnel, but also in terms of Phase 2, a lot of those approval steps, we could have done probably a better job in terms of iterating on a defined desired end state, and then doing a hard look at it and saying, is that really what we want to come out of the software application when it's all said and done? And then in terms of execution, I can also speak to this because I was so deeply involved with the deployment of the software. After the 7-refinery world tour had been completed, Stephen and I sat down and we kind of said, no, you know what, rather than doing all of the refineries at one time, it may have been useful, to sit down at one site, in particular a small refinery, so it's easier to handle the amount of data, and just execute a deployment there and see how well that worked, right? And then you can get into things like the future requirements of the software a little bit quicker, and then you can collate things like lessons learned to share with the other refineries well ahead of time.
And this gets back to the concept of iteration. For example, in our early workshops, we essentially defined 4 iterations for the software, but just based on a prioritization of things that we absolutely required and things that we really wanted. And honestly, what we found was by the time we got done with iteration 2, most of the things that were on iteration 4 were completely changed. And so you have to plan for those iterations as the knowledge and work processes develop.
Got it. And Michaela, I'm happy to hand it over to you so we can get into the Q&A session.
Okay, great. Thank you both for such an excellent presentation. While those questions are starting to file into the Q&A box, I just want to remind everyone, like Stephen mentioned, about ISA's Process Control and Safety Symposium Exhibition, and that's November 7th through the 10th in Houston, Texas in the U.S. Come out and join us. We have some great presentations lined up. I know there is an exhibition portion. One of the days there, you can go for free between 1 and 7 p.m. just to the exhibition. So be on the lookout on the website for more information about when that free day is if you want to stop in, come see some of our Mangan folks and Stephen and things like that. Okay, so I'm going to go over here to this Q&A box, and if we're running too short on time, like I mentioned earlier in this webinar, we'll just hold on to your questions, we'll jot them down, and then we'll have the presenters reach out to you individually so they can answer the questions for you. Okay, first question here. Is there a plan by either Mangan or ISA to create some form of MS project template to support SIS organization creation or operation for gaining ISA84 compliance?
That's a lengthy question there, Michaela. Can you please repeat that one?
Is there a plan by either Mangan or ISA to create some form of MS project template to support SIS organization creation or operation for gaining ISA84 compliance?
Well, that's really a question for Mangan or ISA, but I'll maybe try to answer the question of, is it possible? And I would say certainly yes. One of the exercises that we did with Mangan's help was to define the competencies and define, well, as a roles and competencies matrix. And then once we had the various roles defined, we assigned roles to various activities. So for example, we have required participants in a functional safety assessment. We have the roles that are required to approve an SRS, and on and on. And so I think it's possible and reasonable to put together a template for that.
And certainly in a one-size-fits-all template may be disadvantageous to everybody. So for whoever asked that question, I'd be happy to have an offline discussion with this one, especially when you consider that any one organization will be starting this type of safety lifecycle journey at different points, right? So what we presented here for Chevron Global Manufacturing was probably unique to them in a lot of ways, where you, for any other organization, need to pay attention to some of the attributes of that undertaking, right? Again, defining things like desired end state, talking about who gets what report and when, but then also considering the management style or the management approach, right? With global manufacturing, you had a central team of corporate and technical leaders who were, let's say, guiding the program, not really mandating it so much, but guiding the program across the refineries. That type of culture may not exist in other organizations.
So just one last thing on that. Very generally, I would add that having some sort of management of that is a required part of compliance. So whether you have a template or not, you have to make an effort to manage roles and competencies, and I think the ISA84 standard is getting stronger and stronger on that front.
All right, moving right along. Next question. With usually little structured history available, a past demand, and testing regime, how to capture an optimal frequency?
I assume we're talking about optimal testing frequency. And that's a hard question. I think the answer is basically expert opinion. And so for us, we have a O&M coordinator for all of manufacturing who is responsible for setting those kind of guidelines for everybody. So we try to follow consistent guidelines at all the sites. And then the actual content of the guidelines, he pulled input from basically all the technical people at each of the refineries, as well as myself, and also our energy technology company, who's our technical company within Chevron. So it's simply a judgment call based on the data that you do have, the data that's out there in industry, and your best judgment for what's required.
And then I'd like to add, remember Stephen made mention of things like demand rate analysis and the other aspects of operate and maintain metrics that are captured within the software, but most importantly, analyzed by this central O&M coordinator and the other refineries. So they do look hard at the impact. Even when testing first started, they look at the efficacy of that testing via other metrics.
I would just briefly add that another source of information for this is the prescriptive standards that are out there. NFPA, API, there are lots of standards that predate the risk-based approach that just give guidance on expert opinion.
Okay. Next question. According to your experience, how must be the right owner and administrator of this enterprise software inside organization?
So good question. Let me tackle that one first. From my experience, you're looking for let me say first who should not be the owner of a software tool like this, and it should not be just an IT project manager, right? So that's the risk that any organization runs, where the IT side of the business may have bureaucratic or kind of political control over these kinds of implementations. I think Chevron Global Manufacturing really benefited from the fact that they had corporate and technical leadership, such as Stephen, who were deeply involved and much more involved than IT in terms of selecting tools based on functionality, rather than where maybe IT may be looking for things like past use, right? Stephen?
Well, I think I would give my answer just by describing what we've done within Chevron, which is basically a team-based approach. Alaric mentioned the Change Advisory Board, which basically acts as the owners of the software. But I guess the three key representatives in there is somebody that represents the interests of IT, somebody that represents the interests of the operate and maintain organization, and somebody that represents the interests of engineering. Now, there's overlap in all those, but each one of them is going to bring their own viewpoint to any discussion.
And my comment is just where earlier, I don't want the IT management to be the final decision makers. You know, something like this, where you're talking about, for instance, ISA84 compliance, is about functionality and effectiveness, and not just ticking boxes on an IT project manager's checklist necessarily, though that is important.
Yeah, it's you're not rolling out Microsoft Word. You know, you're rolling out a tool that has to be configured and usable.
Okay. Let's move on to the next question. How do you get buy-in on the time required for data gathering? Years ago, I was asked if I could help a client check a safety system during a shutdown. I said yes, with at least a week on site before shutdown. I was invited on site at shutdown.
Well, I'll try to answer that, and that is a good question and a difficult one, and it's part of a long-term cultural change. If you want a deeper treatment of this, you can look at the presentation we gave for ISA last year, which talks a little more about this. But one of the things that we've had to do is increase the visibility of SIS. One of the key ways for doing that was gathering the testing and demand metrics and making them visible to management. And then a process of evangelization to convince management that this was important enough to get resources assigned to it. A good example that I often throw out is that when you're talking about turnaround work, nobody ever questions whether you have to pull a relief valve and pop test it, because that's just what we do. That's what's required. And somehow or another, in many, many companies, SIS has not received that level of respect. And in terms of risk management, it's exactly the same thing. They're performing the same function, whether you're using a relief valve or a safety instrumented system. You're trying to manage risk.
I definitely agree with that, and coming from the offshore world from several years ago, I can also speak, and I'd like to summarize this as, you know, the culture of short-term cost versus what you might say long-term quality and long-term benefit. And like Stephen indicated there, it's a cultural change that needs to happen, and in particular seeing SIS as not just a cost center, but as really an operations enabler or enablement organization. So do we have time for one more question, Michaela?
Yeah, let's wrap up with just one more question here. Where do we incorporate the SIS calculations in the safety life cycle, and specifically in the SIS verification process?
I suspect you mean SIL calculations. Where do SIL calculations fall within the verification process?
Yes. So I'm going to have a little bit of a nuanced response on that because our SLM tool is able to do SIL calculations, but this is another case where we have multiple systems. We are actually fairly standard on using another tool which we only use for the SIL calculations. So the way we handle that is the results of those calculations are a required document in the lifecycle management database, and then the results of the calculations are entered into the database fields. So we're pretty happy with that solution. It is certainly easy to implement and doesn't change our work process as much. Ultimately, it would be nice to have them fully integrated, but it's just another one of those situations where the work to get rid of one of the other systems involved was not initially justified.
Now, I think the question was, does it, for instance, happen at the initial SRS stage, detailed design?
Okay. We, I would say, have, again, due to our approach, maybe it's an unusual answer, we actually are doing SIL calculations at the template level, which makes some assumptions about the equipment that will ultimately be used. So we have a standard list of approved equipment, and we do the calculations based on that approved equipment. And then when we get into the initial design for the actual SRS, we may find that we can't use some of that approved equipment because we have something existing that we want to reuse, and those SIL calculations would then be updated. And then finally, once you get into detailed design, when the engineering is basically set, that's when you have the finalized detailed calculation. So I would say basically 3 phases: the template phase, the feed phase, and the detailed design phase. So I hope that answers that question. We don't know because we can't hear you.
Well, we've received some great questions, and unfortunately we've run out of time. And like I said, we'll have the presenters to reach out to all of you that asked some of the remaining questions. But we suggest you drop by ISA's PCS and Safety Symposium and come meet them in person and ask them those questions face-to-face. Go to isa.org/PCS2016 to learn more and register. And we did record this webinar, so if you missed any portion of it, or if you'd like to share this presentation with any of your colleagues, that link will be given to you hopefully within the next couple of days. So take a look at that email when I send it to you and find the link, and you can send it off to your colleagues. So we hope you acquired some useful information in today's webinar. Thank you so much for joining us.
Thank you, everybody.
Bye. Thank you.